Okay, finally now we are at the last part of this chapter. So, okay, sine rule and cosine rule. So, what are they? So, sine rule is basically a trigo identity where it says that A over sine A is equals to B over sine B. Okay, so what this means is, so we have your A here represents the side opposite yours angle A. So your angle A is over here. Okay. So this angle A. So your side A is basically the opposite side. Similarly, your angle B is here. So your side B is here. And C is here. Okay. So again, you can manipulate this formula such that sine A over A is equals to sine B over B equals to sine C over side C. Okay, so these are just the trigo formulas. So if you see the second formula is just a reciprocal of the first one. Okay, let me box it up. Okay, so before we move on to the cosine rule, let's do some questions. So the first part is asking you to find this angle. So you're given two sides and one angle. So sine C over 7.5 is actually equals to, then you know your B and the opposite side. Sine 50 over 9.5. Okay? Okay. Also you can, okay, wait. Let me solve this first. So your sine C equals to, okay. So if you plug it in the calculator, you should get 37.2 degrees. Okay, you can also, let's say if you wrote the formula in the opposite manner, then you still get the same answer. So if you make sine C your subject, then you should get this formula either ways. Your sine C goes up, sine 50 comes over, so it becomes 7.5 sine 50, and your 9.5 becomes a denominator. Okay? So yeah. So this is for questions where you have two angles and one side. But what if it's two angles and sorry, over here is two sides and one angle. But what if it's two angle and one side? So again, it's the same thing. Oh, sorry, there's still part two and part three. Okay, so angle A, again, you can use sine rule, but a easier method would be just doing 180 degrees minus 50 degrees minus your part A answer, 37.2 degrees. Okay, then you'll get your final answer. And the last part is your length of BC. So Again, you should be using sine rule. So once you've found A, we should be 22.8 degrees. I'm gonna Okay, so for your part C, you can also use your sine rule. So sine 92.8 degrees over BC is equals to use your given values. So you're given sine 50 over 9.5. So if you solve for BC, you should get BC is equals to oh sorry. Okay, so if you simplify, you should get this. So 12.387 approximately equals to 12.4 cm. Okay, so this is a typical question for questions regarding your sine rule. Okay, so now let's try part B. So now, before we move on to this question, it's very similar to your previous part. So do pause this and try it out yourself. So your angle C, you're given your side 7.6 over sine C equals to, oh sorry, you're given two angles. So your side, your angle C is very easy to find. Angle C is equals to 180 degrees minus 67.6 degrees minus 45.5 degrees. And once you have this, your part 2 and 3. The length of BC. So BC over sine 67.6 equals to, you know your angle C already, so you can use 7.6 over sine 66.9. So therefore BC equals to sine 60. So final, your answer should be 7.639. Okay. Then your last part, length of AC again, use the same method, your sine rule. Okay. So I won't be going through this part. Okay, so now we have covered your sine rule. Well, let's look at your cosine rule. If you need, take a quick break and then we will continue with the cosine rule. Okay, so your cosine rule says a square equals to b square plus c square minus 2bc cos a. Okay, so again you can manipulate Uh, it's very similar to your area area formula, area of triangle. So if you see, right, your a square here is actually equals to your other two sides, your b square plus c square, minus 2bc cos a. So minus 2bc and then the angle in between bc, which is your angle a. Okay? So again, if you want to find b square, then your two sides will be c square plus a square minus 2ac cos b. Okay? And if you wanna find c square, so it should be b square a square plus b square minus 2ab cos c. Okay? So it's quite straightforward. So this is if you want to find the sides, okay? A square plus c square minus 2ac. In a case where you want to find the angle, again, it's just manipulating the equation. So if you're trying to find cos A, so your cos A is equals to A square minus B square minus C square. Sorry, you get, because if you make your 2BC cos A the subject of the equation, you'll get uh, B square plus C square minus A square. And then if you bring the 2BC over, you'll get 2BC. Okay, so these are your formulas for cosine. Again, your cos A, you can also find cos B and cos C. Okay, so these are just manipulation of equation. Okay, so once you know this, let's do a few examples. Okay, this is a very good question for sine rule. Uh, yeah, let's do some cosine rule questions first, and then we move back to the previous one. Okay, so in this case, you're told to find the length of AB. Is it possible for you to use your sine rule in this case? You can't, right? Because let's say if you do AB over sine 67 equals to, you don't have any other angles, correct? So uh you need at least two angles or one angle in the corresponding side. So we don't have that, so we have to use cosine rule. So always whenever you're doing like questions related to triangle, right? Your first thing you should look at is whether it's a right angle triangle. So if it's right angle, then you won't need to use cosine and sine because trigo is easier. Okay, so always use trigo first. Always use Pythagoras, then trigo. Then if it's not right angle, use your sine and cosine rule. So check whether your sine rule is available, and if you can't use your sine rule, then use your cosine rule. Okay, so your part one, they ask you to find AB. So AB is basically AB square is equals to uh, your other two sides, which is 8.8 square plus 10.4 square minus 2 times 8.8 times 10.4 times cos angle opposite your side AB, which is cos 67 degrees. Then you just type this whole thing in your calculator. So you should get You should get your final answer should be this one should be 114.1. Then AB should be equals to 10.7 cm. Okay. So once you find your AB, your next one, your wait, sorry, 10.7. Okay. Next one, the question asks you to find angle ABC. So angle ABC, now you can use a sine rule since you have one side and the corresponding angle. So ABC, sine ABC over 10.4 sine 67 over 10.7. Okay, so just simplify this. You should get angle ABC equals to 10.4. Sorry. Okay, so if you solve this, you should get 63.7 degrees. And then your last part, find angle BAC. So this should be simple. It's just 180 degrees minus angle ABC minus 67 degrees. So you should get 49.3 degrees. Okay, so this is how you use your cosine rule. So if you see, normally you only need your cosine rule for your first part, and then for the subsequent parts you can use your sine rule, because sine rule is easier to compute it. Okay, let's take a look at another example. So the question asks you to find angle ADB. ADB. Okay, so in this case, if you just look at this triangle, you are given three sides, but you don't know any angles. So if I want to find ADB, one method I can think of is finding ADC and then doing 180 minus angle ADB. Okay, so I find this angle first and then doing 180 minus that angle. So when you have three given sides, you can always use your sine rule. Okay, sorry, your cosine rule, not sine rule. You need at least one angle and the corresponding side for your sine rule. So angle ADB. So 4.5 square. If this is my angle of interest, I should look at the opposite side. Equals to 3.5 square plus 2 square minus 2 times. So when I simplify this, cos angle ADC, I would get 16.25 minus 4.5 square over 2 times 3.5 times 2, 14. So in this case, I would get minus 2 over 7. And it makes sense why it is minus because it's a obtuse angle. Okay, so remember your trigo identities that we learned earlier. So for cosine, if it is more than 90 degrees, it should be a negative. So given that it's a negative here, that means you're going on a right track. So therefore your angle ADC equals to 180 degrees minus. Okay, if you want we can straight away find angle ADB here, because angle ADB equals to 180 degrees minus angle ADC, correct? So you can use your cosine identities. Uh, cos go ADB equals to negative cos ADC. So equals to 2 over 7. Therefore, angle ADB, then you should get should get 73.4 degrees. So if you do it you can either do it this way, or you can find angle ADB first. So angle ADB, sorry, ADC. You'll get 106.6 degrees. So therefore angle ADB equals to 180 degrees minus this angle. So you get the same answer, which is 73.4 degrees. Okay. So do whichever method that you're comfortable with. So there are many different methods. And then the next part is asking for the shortest distance from A to CB. So your shortest distance is always your perpendicular distance, okay? So do know that. Perpendicular distance basically means that the angle it forms when AX touches CB is actually equals to 90 degrees. So in this case, uh, what do you know? So you know this angle, you know AX, sorry, you don't know AX, you're trying to find AX, but you also know this angle which is 90 degrees, and you don't know AB. So if you find angle AB, sorry, the side AB, then you can use your sine rule. So let's see, can we find AB? Yes, okay. So we can use your sine rule to find angle AB. Sorry, your side AB. So this angle is calculated to be 73.4. Okay. So AB over sine 73.4 equals to 2 over sine 50. So if you calculate AB, you should get equals to 2.5020, approximately 2.50. Okay, so now you have found that this is equals to 2.50. So once you have this, you can use your sine rule to find your perpendicular distance. So AX over sine 50 equals to AB over sine 90. And your AB here is 2.5. So therefore your AX is equals to The final answer is 1.9151, approximate 1.92 cm. Okay, so this is your part 2 done. And then your part 3, the length of BD. So again, this should be simple. You can just use your sine rule again to find your BD. Or you can also use your cosine rule. This, yeah. But sine rule will be easier. Okay? Alright, so this, I want you to try this part by yourself. I will go through during lesson. Okay, so this is a typical question for your cosine rule. It's a combination of cosine rule and sine rule. I would say this question is fairly challenging because there are like many new concepts. But don't worry, we are going to do more practice during your lesson. But this is how a general question for cosine rule will go, especially for your advanced levels. Okay, so now let's look at your last part, which is your sine rule but ambiguous case. Okay, so you're given, always draw it, okay? A, B, C. You're given that angle ABC is equals to 55 degrees, AB equals to 16.3, AC equals to 14.3. So question asks you to find angle ACB. So ACB. So sine angle ACB equals to over 16.3. If you use sine rule, that's how we do it. It's sorry, AC is actually equals to 14.3. So this equals to sine 55 over AC, which is 14.3. Okay, the way I see it is always look at the angle and straight away look at the opposite side. Okay? So find angle ACB. So again, just manipulate the equation. Angle ACB equals to sine inverse. Um, then you can find your answer. Okay, so once you find angle ACB, BAC, and the length of BC should be simple. It's just again your sine rule and other formulas if required. Okay, so why is this an ambiguous case? Is because you can also draw the triangle like this. I don't have much space, so I'm gonna give it. Okay, so why is this an ambiguous case? Is because you can also draw your triangle like this. So again, it's the same triangle, just that in this case, your ABC looks something like this. A, B, C. So in this case, you see your AB, angle ABC is still 55 degrees. Then AC is 14.3 and AB is 16.3. So this is the second case where your angle ACB is actually more than 90 degrees, so it's obtuse angle. So again, if you use the same formula, you would get the same thing. Angle ACB equals to all this, but in this case it would be 180 degrees minus this thing. Okay. So yeah, this is about it. So the first one should give you 69.02 degrees. Then this one should give you 110.98 degrees. Okay. So these are the two different cases. Just take a note for, especially for sine, whenever you see sine x, x can be either equals to 180 degrees. Sorry, the first case would be just sine inverse x, or it can be sine inverse angle, or it can be equals to 180 degrees minus sine inverse angle. Okay, so these are the two different cases, especially keep a extra lookout for sine. And when you see like the question doesn't draw you a triangle and ask you to find the angle, and when you have to use your sine rule, then it's quite obvious that there are two different possibilities. So in this case, you would have six different answers, okay? Because you have two different values for ACB, BAC, and the length of BC. Okay, so that marks the end of this chapter. So let's do a quick summary. So we have learned obtuse angle, you have two different formulas. Sine A is equals to sine 180 minus A, and for cosine is just a negative sign in front. Cos A equals to cos, negative cos 180 degrees minus A. Then, wait, I missed out. So for area of triangle formula, it is half AB sine C. So you use this when you don't know the height. Sine rule is simple. It's just side A over angle A equals to side B over angle B over side equals to side C over angle C. And then cosine rule is very similar. If you are interested in AB square, then it will be, okay, wait, sorry. Let me write. If you're interested in your A square, so in this case, when you draw a triangle, so this is your A, this is your B, this is your C. Okay, so your A square is equals to B square plus C square minus 2BC cos, and your angle should be A. So A over here is also equals to angle BAC. Okay, so this are the formulas that you have to know for this chapter. It is quite a content heavy chapter, so come to me for extra support if you're unsure about any concepts. I will go through and we will do more practice during our lesson time. Okay, so that marks the end of this chapter. Thank you for watching.